Guys, what's up? I am Saiasmi Gupta, co-founder of 10x Coder Kids, and today we are gonna be learning the difference between periodic motion and oscillatory motion. So people get confused on about this concept. So this is class 7's concept. Oh wait, 1 second. So this is a class 7th concept which is going to help you in your further classes also, right? So today we're going to be learning about the difference between periodic motion, periodic and oscillatory motion, right? Oopsidizes. Oscillatory motion, right? Today we are gonna be learning about this. So I'll also be giving you examples so that our concepts are crystal clear, right? So basically, what is periodic motion? Let me just clear this out because it's kind of distracting. Okay, so periodic motion. Let me tell you about periodic motion. Repetition of a motion done by an object in equal intervals of time. Now you might be thinking, what am I saying? Because of which I have examples which are going to explain you much better. Now, right. So the best example of periodic motion would be that the earth revolves around the sun. Right. So let me show you. Give me a second. I'm going to try to give you the best example as much as possible. Okay. So here we have our sun. Yellow. Pretty. And then it's gonna be tiny. Right. So we all know one thing. What do we know is that the earth revolves around the sun, right? First example is earth revolving around the sun. Around the sun. Right. So the best example is earth revolving around the sun. So we all know that in 365 days, it takes the earth 365 days, which is equal to 1 year. 1 year, right? So basically the earth takes 1 year to complete one round around the sun, right? Then it basically look, here we have our sun, basically our earth, right? It's taking a round, it's taken a round, it has been an year, and it has come to its starting point. Now it has been 1 year. Now again it's taking the same round, and it has come to its starting point again. Then it's taking its same round, and it's on its starting point again. So basically, the earth continuously takes rounds around the sun, right? It takes rounds around the sun. Oh god. Right. It takes rounds around the sun. Okay. It takes each 1 year each to take a round around the sun. So it is repeatedly performing this, right? It's continuously taking rounds and rounds and rounds and rounds around the sun each year, right? So, this is one example because repetition is happening, right? And in equal intervals of time. After 1 year, it again takes the same round, right? After the second year, also it takes another round. All the years go by and keeps on taking rounds, right? So, that is what it is. Okay, so I'll erase this. Once again, don't think that you are not able to hear me. I am just writing. Now, what motions does the earth while when the earth revolves around the sun, it performs motions, right? So which motions does it do? First of all, it performs the periodic motion. I've already explained you how, because it continuously, repeatedly takes circles around the sun in equal intervals of time. After 1 year, he is done with its one circle. Now it will again do a circle, right? So repeatedly it happens. So periodic motion. Then there's another motion, circulatory motion, because as the name suggests, it goes in a circle, right? So it performs circulatory motion as well. Okay? Circulatory motion. Right? So this was one example. Now let's take this aside. Now the next example is of pendulum. Now pendulum really confuses almost everybody, but you're not gonna be a person who gets confused in the pendulum. I think it's actually pretty easy. So, what does a pendulum look like? Sorry if my drawing is horrible. I also know my drawing is horrible. Right. So we know this is how a pendulum looks like, right? Is this how a pendulum looks like? Yes, this is how a pendulum looks like. So, the pendulum is attached, basically it has three parts. The top part, right, which holds the thread, right? it holds. It's basically a base kind of, you know what I mean. It basically holds basically the this top part, which I'm coloring right now. It's attached with this thread, and this thread is attached with this metallic ball, which is known as the bob. Now, it's not that important that you basically buy a pendulum. You can make a pendulum. Just make a strong base like this, take a thread and just basically tie it with a rock, and there you will have it. This would be the bob, and your pendulum would be made at your home, right? Now I'm doing it quick. It's okay. So basically, pendulum has a repeats its motion, but it has a to and fro motion, right? It has a to and fro motion. Why? Because this is its mean point or the average point, right? Right now it is its average point. It would first go here, right? Then it would go here, then it would come here, right? Now, why am I explaining you this? Everybody knows this, right? You might be thinking, what? So let me right now just tell you that pendulum is an example of a periodic motion. Now, why is pendulum an example of the periodic motion? Pendulum is an example of the periodic motion because it repeats its to and fro motion, right? It repeats it and it takes in equal times. For example, here is the pendulum, and first here, then it came here, then it came here, right? So it took it 1 second. Then in the second it would again go here, and it would take another second, then another second, then another second. So it repeats its motion, right? So that is why pendulum is periodic motion. Now I'll explain you about pendulum ahead also, but right now I need you to understand that pendulum is the performs periodic motion, right? And it also performs oscillatory motion. Now, I was not explaining you pendulum because you first need to know what is oscillatory motion, right? Because that is our topic today, difference between oscillatory motion and periodic motion. When you'll understand oscillatory motion, then you would be easily be able to understand pendulum. Okay, so let me tell you oscillatory motion. Once again, I'll draw a pendulum here. A fast drawing, horrible drawing, I know, thank you. A pendulum, right? And this is a bob. Okay, so let's understand about oscillatory motion. Now people always get confused in between these. Now, first of all, oscillatory motion is a specific type. It is a specific type of the periodic motion. Now, how so? That is because I know you are not able to understand my handwriting, isn't it? I'll make it look readable. I want you to make notes also, right? I hope you're making notes. Specific type of periodic motion. So before, when we were doing periodic motion, we had learned. I had given you an example of Earth revolving around the sun, right? So in the periodic motion, it's basically repetition of a motion which happens in equal intervals of time, right? It does not matter. It can be in a circle, it can be in a straight motion, it can be in any way. It can be a true to and fro motion. Also, an example of periodic motion is a seesaw. Now, seesaw and the pendulum perform the to and fro motion, right? Now, we have revised the periodic motion. Now, where were we? We were learning how we had a question why, how is oscillatory motion a specific type of periodic motion? Right. It is how, because oscillatory motion is the to and fro motion done by an object in equal intervals of time. Whereas in periodic motion, we had not specified, right, that to and fro or anything. It just it has to repeat it again and again in equal intervals of time, right? But so this is how it is a part, because the pendulum performs the to and fro motion. How is it so? Because this is the average or the mean point, okay? First, the pendulum would go here, right? Then it would go here. Then it would come back here, right? So, now it's known that the pendulum performs the oscillatory motion. The pendulum performs the oscillatory motion, because of which, when the pendulum from here goes to its extreme right, then comes back here and goes to its extreme left and comes back here, that is known as one oscillation, that the pendulum has completed its one oscillation. Okay guys, that's why. And the time took the pendulum to perform basically complete one oscillation is known as time period. What is it known as? It's known as time period, right? So I'm just gonna use a new note now, because it's getting a bit messy. So that's why the to and fro motion, it's important. Any object that performs a to and fro motion repeatedly in equal intervals of time is an oscillatory motion. Does oscillatory to and fro motion, which object does to and fro motion has a to and fro motion has oscillatory motion. Okay, understood? Crystal clear? Now, one note which is very, 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 very important, which I want you to write it. It's compulsory for you. That is that that the objects the objects which perform oscillatory motion perform periodic motion as well. No, this is wrong. Actually, this is wrong. Basically, all oscillatory motion performing objects perform periodic motion as well. But it is not vice versa. Basically, what this note means is any object that performs oscillatory motion, like the pendulum performs the oscillatory motion, right? That all the objects which perform oscillatory motion, the to and fro motion, perform periodic motion as well. But for example, the earth revolving around the sun performs periodic motion, but the earth revolving around the sun is not performing to and fro motion, right? Because of which it is not vice versa. Not all periodic motion performing objects are oscillatory motion performing objects. Okay, so this was one important note. Okay, if you would see my video, just rewind it a bit back and see it again, then you would understand it much better. Okay, sorry about that. So this was it. Just I would like to explain you, in the last class of science lessons I forgot to tell you about uniform motion. That uniform motion, the graph we did, right? That the uniform motion does not has two types. Wait, let me show you. Remember, this is the y-axis, this is the x-axis, this is the time, this is the distance, right? And this is 0, 1, 2, 3, 4. 1, 2, 3, 4. Right? So we had learned in the earlier class that uniform motion is like this, but there's more types of uniform motion. One can also be like this. Now this uniform motion represents that the person or whatever it is has high speed. Now how is that so? That is so that in 1 hour, no, what am I saying? This represents high speed as oops, what am I doing? As in here, look, it covers 1 kilometer in only 0.5 hours or 30 minutes only. In it covers 2 kilometers in one in the other 30 minutes. Then 3 kilometers it covers in the other 30 minutes. Basically it's taking 30 minutes instead of 1 hour, right? And now this is the last thing and then we'll end it. So this high speed, this graph had represented high speed, and this is the x-axis, y-axis, time, distance, right? And 0, 1, 2, 3, 1, 2, 3, 4. And sometimes in uniform motion only, the line comes like this. Now this represents low speed. What does it represent? It represents low speed. How? I'll show you. It covers 1 kilometer in 2 hours. It covers 1 kilometer in 2 hours, and basically 0.5 kilometers in 1 hour. Then 2 kilometers it covers in 3 hours, and 1.5 kilometers. No, it covers basically 2 kilometers in 4 hours and 1.5 kilometers in 3 hours. Okay, so this is what it is, right? So this represents low speed. And it was it, guys. I hope you really liked my videos and understood the difference between oscillatory motion and periodic motion, understood about the pendulum, and I even told you these uniform motion and stuff. So yeah, guys, thank you guys, and bye. Stay safe.